Hmm. 11:30. Is everyone able to visualize the presentation? Anybody can unmute your mic and say, is presentation visible?
Yes, sir.
Yeah, let me check in the chat box. Is it audible to all? Okay, thank you. So from your chat information, I understood that you are able to see the presentation as well as you are able to hear my voice. So in today's class, what we are going to see is we are going to deal with the problems that we are going to see in unit number 2, so which is information channel. So in the last class we had seen about information, mutual information, entropy, conditional entropy, differential entropy, followed by channel coding theorem, binary symmetric channel, and some of the applications of them. Okay, so how do we implement that with with their relevant problems is what we are going to see today. Okay, and we'll be seeing some of the problems based upon the mutual information, entropy, channel coding theorem, as well as a signal to noise ratio and its trade-off with the channel capacity. So for this, we should be familiar with the formulas. Okay, don't worry. Whenever we solve the problem, formulas will be already being highlighted. So I'll highlight the formulas, then we'll solve how to do it. Okay. So let's go into the presentation, which is this. So information theory and coding, unit number 2, solutions to the problems in the information channel. So the first question and its solution is the relation which we had obtained as a property for mutual information that we are going to prove. So what we are going to prove is that the first property. The first property is that the mutual information can be expressed in terms of entrophies. Mutual information can be expressed in terms of entrophies. with input and output conditions. So if I have two variables x and y which are randomly being generated, the mutual information between x and y can be given in these two, h of x and h of y. So now we are going to prove this. So the first proving relationship is that I of x is to y is equal to h of x minus h of x by y, or h of y minus h of y by x. So this we are going to prove in as your first solution. So before starting that, we should see what is I x of I x is to y. So I x is to y is that x and y are dependent on each other. This states that x is obtained as an output with y relation, or y depends on the input of x. So they are mutually dependent to each other. So this is what mutual information is. So the mutual information carried out from x to y is I of x is to y. Second, h of x is entropy of x variable alone. H of y is entropy of y variable alone. And we have another thing called h of x bar y, or x by y. So which we call it as conditional entrophies, ratio between x to y or y to x. So these are your conditional entropy. So according to the definition of conditional entropy, which we had seen in the differential entropy, the h of x by y is always written as the equation 112.9, which is being highlighted. Okay. Conditional entropy is written as h of x bar y is equal to summation I is equal to 1 to n, because our x variable varies from 1, 2, 3, 4 till n. Similarly, for y it varies from j is equal to 1 to m. So j is equal to 1, 2, 3 till m. So probability of xi comma yj log to the base 2 1 divided by probability of xi divided by yj. So why you are writing xi by yj is that we are having conditional probability with respect to x by y. So xi by yj. Xi is your random variables probability for x, yj is random variables probability yj. So h of x bar y is the information in uncertainty conditions in x after y is being received, or you can say that h of x by y is the information lost in a noisy channel. And the average conditional self information is different, and mutual information is different. So keep in mind, self information represents the information obtained only by that particular variable, whereas mutual information represents the information provided which is depending upon the other variable. Okay, so conditional and mutual. So we'll take the mutual information, so which is the equation I of x is to y, I of x is to y, summation I is equal to 1 to n, summation j is equal to 1 to m, probability of xi yi log to the base 2 of probability of xi by yj divided by probability of x of y. So this equation is 1.12.2 we had seen in the last class, which is mutual information, which is a mutual information. So let us write this above equation in this form also. Okay, so which can be written as I of x is to y is equal to summation I is equal to 1 to n summation j is equal to 1 to m probability of xi comma yj log to the base 2 of 1 divided by probability of xi minus summation I is equal to 1 to n probability, sorry, summation of j is equal to 1 to m probability of xi comma yj log to the base 2 of 1 divided by probability of xi by yi. Okay, we are separating it in writing. So when you separate it, we'll be writing log to the base 2 p of xi by yj in terms of plus. I require in some places it as minus for proving, so I'm taking inverse of that. So 1 divided by p of xi by yj, where I'll be putting minus in front. So from this equation, we can rewrite it as, okay, I of x is to y is equal to summation I is equal to 1 to n, summation j is equal to 1 to m, probability of xi yj as it is logarithmic base 2 1 divided by probability of xi minus h of x by y. So I can see that this equation 1.12.10 h of x of y, recall it from 1.12.9. Okay, if you substitute that here, we'll get 1.12.10. Now this is your standard probability relation, which is given by summation j is equal to 1 to m. We are taking only the y value. J is equal to 1 to m probability of xi comma yj is equal to probability of xi. So this is your standard probability relation. So if the standard probability relation can be written as this, we can substitute that here. Okay, can substitute instead of summation j is equal to 1 to m probability of xi yj as probability of xi. So then we'll get equation 1.12.11. 1.12.11 will be your equation. So then the first term, h of x, the first term in equation 1.12.11 is always your h of x. Definition by your information. H of x is equal to summation I is equal to 1 to n probability of xi log to the base 2 1 divided by probability of xi. So substitute that in equation 1.12.11. Simple. We'll get the first proving I of x is to y is equal to h of x minus h of x by y. So the I of x is to y is the average information or the mutual information transferred per symbol, and this is equal to the source entropy, which is h of x minus of the information lost, which is your conditional entropy in the channel. Okay, so this is your first one. So we are to the first relationship, which is your property of your mutual information. Similarly, we have to prove it for second, which is I of x is to y or I of y is to x is equal to h of y minus h of y by x in the same manner. Okay, so expand the relation as we have done in first proving I of x is to y or I of y is to x. This states that I of x is to y or I of y is to x is always symmetric in nature by the first property. Okay, sorry, by the properties of mutual information. So we can write in terms of x varying from 1, 2, 3 till m and j varying from 1 to 3 till m. Probability of xi, yj log to the base 2 of, we'll write in terms of y and j. Yj divided by xi divided by probability of yj. So bring the y component outside as we had wrote. Then we can rearrange it as seen in the first proof. Summation j is equal to 1 to m, summation I is equal to 1 to n, probability of xi, yj log to the base 2, 1 divided by probability of yj. Minus, as we had done previously, summation I is equal to 1 to n, summation j is equal to 1 to m, probability of xi, yj log to the base 2, 1 divided by probability of yj divided by xi. Equation number 1.12.4. So this would be more or less similar as this equation. I'll show you this as this equation, as this this equation. So it will be more or less similar. So now the conditional entropy h of y by x is given as h of y divided by x is equal to summation I is equal to 1 to n, summation j is equal to 1 to m, probability of xi, yj log to the base 2, 1 divided by probability of yj divided by xi. Now, as we had considered in the previous, consider the uncertainty in y when x was transmitted. So we'll be getting, instead of this equation, you can substitute h of y by x as it is. So remaining will be same. I of y is to x, summation j is equal to 1 to m, I is equal to 1 to m, n, probability of xi comma yj log to the base 2, 1 divided by probability of yj minus this. So instead of this, we substitute conditional entropy. Now we have our standard probability equation for y. So it will become I is equal to 1 to n, probability of xi yj is equal to probability of y of j. Equation 1.12.17. So then substitute this in 1.12.16. We get I of y is to x, j is equal to 1 to n, probability of yj log to the base 2, 1 divided by probability of yj minus the conditional entropy h of y by x. So this is obviously known to all, the entropy of y variable. So h of y minus h of y by x. So this equation is similar to your previous equation. This second, I of x is to y or I of y is to x is equal to h of y minus h of y by x. So thus these two are being proved. Any doubts in these two? Let me click in chat box. Okay. If you are having any doubts, you can put it in chat box, such that after each and every problem, I'll check it and I'll give you an appropriate queries. I'll be addressing your queries. Yep. Because I cannot simultaneously see the chat box and the presentation simultaneously. It cannot be viewed. So that's what I'm checking. Okay, nothing. Then we'll proceed. Okay, moving on to the next problem, which is also a proof for solving properties of mutual information. So the property is that The mutual information is always positive. It cannot be negative at all. In the sense I of x is to y is always greater than or equal to 0. We are going to prove this also. So for this we'll be taking our known equation, which is probability of not probability, sorry, it's mutual information again. The mutual information I of x is to y is equal to summation I is equal to 1 to n, summation j is equal to 1 to m, probability of x of I, y of j, log to the base 2. I'll highlight it, okay. Log to the base 2, probability of x of I divided by y of j, whole divided by probability of x of I. And then this equation is your standard relationship between this equation is standard relationship between the symmetricness. So from the symmetricness or the symmetric equation, we'll be writing p of x of I divided by y of j is equal to probability of x of I comma y of j divided by probability of y of j. So substitute this value in this equation, we'll be getting this I of x of y summation I is equal to 1 to n, j is equal to 1 to m, probability of xi yj log to the base 2. Instead of p of x of I by yj, substitute p of xy yj divided by pyj. So you'll get this probability of x of I comma y of j whole divided by probability of xi, probability of yj. So here this probability of xi comma yj is mutual, whereas here it is independent. Now we can simplify this log, logarithmic x by y, which can be rewritten as minus logarithmic of y by x. Hence this equation will become minus summation I is equal to 1 to n, summation j is equal to 1 to m, probability of xi yj plot to the base 2, write this in inverse. So we'll get probability of xi, probability of yj divided by probability of xi and yj. Now this can be also further rewritten as bring this minus that side. Bring this minus towards that side. So we'll get minus I of x is to 1.12.20 equation. Now there is a standard relation. This is a standard relation which this is a standard relation. Summation k is equal to 1 to m pk logarithmic to the base 2 qk divided by pk is less than or equal to 0 always. This is your standard relation of probability function in terms of mutual information. So this is applied to this 1.12.20. Now we consider here what is pk is that probability of x of I, y of j, and qk to be as probability of xi and probability of yj. So since both the pk and qk are two probability distributions with the same alphabet, so here you can see that x variable, y variable. Here also x variable, y variable. So these are in same. So instead of this we can write pk. Here pk, and instead of this here we can write qk, here we can write pk. So which is always less than or equal to 0. So here it is minus I of x is to y is less than or equal to 0. So now this minus is there, keep in remembrance. So bring that minus that side. So it will become I of x is to y greater than or equal to 0. So this states that the mutual information is always non-negative, or it is always positive. Mutual information is always positive. So this is your proof for that. I think it is your third property. I think so. Third property. Yeah, maybe third property. Yeah, third property of mutual information. Coming on to the third third problem, we are going to see this third problem is also a property of mutual information where the mutual information is related to the joint probability, which is I of x is to y is equal to h of x plus h of y minus h of x comma y. Here you will be asking me, sir, you said about two different entrophies. One is conditional entropy, another one is joint entropy. Which one is what, sir? I'll show you. In the previous, here we had seen h of x by y is your conditional entropy. So x over y and y over x is your condition. Okay, this is your conditional entropy. Whereas this h of x and h of y is entrophies. Entropy of x and entropy of y independently. And whereas here this h of x comma y is your joint entropy. Joint entropy. Okay, so already we had seen h of x comma y is always h of x by y plus h of y, and from this we can find h of x by y is equal to h of x comma y. Bring this that side, interchange, will be getting minus h of y. The simple thing is that we are interchanging its positions. Okay, so this plus h of y is brought to that side. H of x comma y minus h of y is equal to h of x by y, and I'm rearranging it in terms of h of y, x by y. So which is h of x by y is equal to h of x comma y minus h of y. Okay, so the mutual information is already known. I of x is to y is equal to h of x minus h of x by y. So simply substitute this equation here. This here we'll get this equation here. We'll get I of x of y is equal to h of x. So minus of minus we'll get plus. So plus h of y, and remaining will be minus. So minus h of x comma y. So this is your proof for property number 4, I think so. Property number 4 of mutual information. Before going to a problem, let me check any questions or queries for these two, 2 and 3. Shall we proceed for the next problem, which is based on binary symmetric? Why? Because so far what we had seen three problems is based on mutual information. They are purely based upon mutual information. This is entirely is separate, which is which is in sequence to that, which is called as binary symmetric channel. So if you want to solve a binary symmetric channel, we should be familiar with this diagram. This binary symmetric channel diagram. You need to recall the binary symmetric channel how we are drawn. We are having m is equal to 2. So this question will be given. Okay, this diagram will be given. Need not worry. If it is not given also, you should be in a proper position to draw it. So most in 99% cases, they'll be giving you a diagram. If not, you need to realize, you need to see how to draw a diagram. So for binary symmetric channel, we have two symbols, x and y, with two variables, x1 and x2, and y1 and y2 as outputs. X is all input, y is always output, and if there is an input bit with some probabilities, if it doesn't changes the output, some input is there, some output is there, the output is obtained, and if something is given along with the input, if it doesn't changes, we don't have any probabilities. So we don't have any what you call probability of error. We don't have probability of error. So which is 1 minus alpha. If we have a error, we have alpha. So this is a condition. So this you need to keep in mind. With that, the binary symmetric channel is being drawn. We need to find h of x, h of y. We need to find h of y by x and I of x is to y. So what is this h of x? H of x is your entropy of x. H of y, entropy of y. H of y by x is your conditional entropy. I of x is to y is your mutual information, not entropy, mutual information. Okay, so from the diagram we can illustrate that probability of x of 1 is always p, and probability of x of 2 is always 1 minus p. Okay, so now we'll see how do we get y1. Okay, how do we interpret y1? So y1 can be obtained in two cases. One is by giving something to x1 and by giving something to x2. So find what it is. So if I want y1, there are two different cases. If I apply x1 with 1 minus alpha, okay, so y1 over x1, y1 over x1 is always 1 minus alpha. So that is one equation. And another thing is that y1 can be obtained even from x2. So y1 over x2 is alpha. Is alpha. Is alpha. Similarly, for y2 we need to find. For y2 over x1 is alpha. Y2 over x1 is alpha. And y2 over x2 is 1 minus alpha. So here it is 1 minus alpha. So in a single line, it's being written. Property of y1 by x2 is equal to property of y2 by x1 is equal to alpha. Sorry. Then probability of y1 over x1 is equal to probability of y2 over x2 is 1 minus alpha. Now to find h of x, entropy of x, we know the formula. Since there are two symbols having probabilities of x1 as p and probability of x2 as 1 minus p, which is given. Since there are two, so we'll be writing h of x is equal to summation I is equal to 1 to 2 probabilities of x log to the base 2 1 divided by probability of that x. Okay. So since you are having two symbols p and 1 minus p, so p into log to the base to 1 by p plus 1 minus p log to the base 2 divided 1 divided by 1 minus p. Okay. So this function is called as horseshoe function. So this is a entropy of x. This equation what we wrote h of x is equal to p log to the base 2 1 divided by p plus 1 minus p log to the base 2 1 divided by 1 minus p is entropy of x for binary symmetric channel, and this is also called as horseshoe function. Similarly, we'll be finding it for h of y. Okay, so how do we find h of y is that the standard probability relation p of yj is equal to 1 is to summation 1 is to not 1, it is summation I is equal to 1 to n probability of xi yi. So from this we can relate it. How do we put xy comma yj is that in this fashion, probability of yj is equal to summation I is equal to 1 to n probability of yj divided by xi into probability of xi. Since we have two symbols, we can write I is equal to 1 to 2 probability of yj, so xi. Since 2 it is y1 xi or p of xi, and similarly p2 or not p2 y2 xi. We can expand the first one, probability of y1 x1 into probability of x1 plus probability of y1 x2 into probability of x2. So since there are two symbols for y1 and y2, we need to find it separately, and due to this we get four combinations, so we need to write separately. So we get totally four: y1 having x1 x2, y1 having x1 x2, and y2 having x1 x2, so totally there will be four. So first we'll write it for y1. So for probability of y1, p of y1 over x1 into p of x1 plus probability of y1 bar x2 probability of x2. So this is an equation. Then another is that for y2 we have two symbols for x 1 and 2, so probability of y2 over x1 probability of x1, probability of y2 over x2 probability of x2. So in this what we are going to do is that we are going to simply substitute p of x1 value, p of x2 value. P of x1 is p, p of x2 is 1 minus p. Just simply substitute it here. And we know that we have a relation also. Here we have relation p of y1 over x2 is alpha, or y2 over x1 is alpha, y1 over x1 is 1 minus alpha, and y2 over x2 is 1 minus alpha. So substitute all this 1, 2, 3, 4, 5, 6 in equation 1.12.27 and 1.12.28. So we'll get this equation. P of y1 will be 1 minus alpha Probability of x1 is p, and probability of y1 over x2 is alpha. Probability of x2 is 1 minus p. So simplify. We all are you all are very much intelligent in simplification. You know how to rearrange it and simplify. We'll be getting alpha plus p minus 2 alpha p. Okay. Similarly, substitute those parameters of 6 in equation 1.12.28. We'll be getting p of y2. Rearrange. We'll be getting some parameters which will be cancelled. So at last we'll be getting 1 minus p of y1. Just p of y1. Now the entropy can be calculated. The entropy of y can be calculated easily, which is Horseshoe function of probability of y1. And from this we can write h of y is equal to probability of y1. You can see that we know that probability of y1, horseshoe function of y1 is this p plus alpha minus 2 alpha p. So we can write this equation. So this is entropy of y. Equation 1.12.30. So next is to find what h of x is found, and here it is h of x 1.12.25. h of y is found here, equation 1.12.30. Now we need to find h of y by x, which is your conditional entropy. So the conditional entropy formula is this, which we had seen earlier. So substitute the values which are having two symbols. We are having 2, so I is equal to 1 to 2. Probability of xi, probability of j separately, then we'll get j is equal to 1 to 2. Probability of yj xi log to the base 2 1 divided by p of yj by xi. So this we had already found just now. This we had found just now, which is alpha. So you can write, this is the equation, which is horseshoe function of alpha. So if entropy is found, joint entropy can also be easily found. Next up is to find mutual information. Mutual information. Mutual information is I of x is to y or y is to x. Both will be same. You can write it as h of y. Since we have found y by x, we will be writing h of y minus h of y by x. So h of y is here, and h of y minus y by x is here. So simplify these two in this equation. I of y is to x is equal to horseshoe function of p plus alpha minus 2 alpha p minus horseshoe function of alpha. So this is your mutual information. And always by your symmetric property, mutual information of I of y is to x is equal to mutual information of x is to y. And keep make a note that This is valid only for BSC channel. BSC, binary symmetric channel. This is valid only for binary symmetric channel. So any doubts in this? I will keep this binary symmetric channel for 2 or 3 minutes such that you can visualize how to draw this binary symmetric channel easily. Yeah, coming back to the binary symmetric channel. So now in the next question, what we are going to do is that in the same channel, same diagram, we are going to add some parameters. Instead of some notations, we're giving it some values of parameters. So where we are substituting the value for p as 0.1 and beta as 0.5, where this beta is only for probability of x1. Probability of x1. And we need to show that I of x is to y is equal to h of y plus p log to the base 2 p plus 1 minus p log to the base 2 1 minus p. So this is what we need to find. Okay, this is we need to prove it first. We'll prove this, then we'll determine the values of I of x is to y for p is equal to 0.1 and beta is equal to 0.5. So where beta is this P of x1. So let us see. We'll draw the diagram. We'll draw the diagram first. So it is a given diagram. Okay. From the diagram, they should be interpreted clearly. The interpretation from the diagram is the first and foremost thing in a binary symmetric channel. So the given is again binary symmetric. So two variables x and y having m is equal to 2. So x1, x2, y1, y2, and probability of x1 over probability of p of y1 over x1 is equal to 1 minus p of y2 also p of y2 over x2 is 1 minus p of y1 over x2 is p of y2 over x1 is p, and they had given that p of x1 as beta. So if p of x1 is beta, p of x2 is 1 minus beta. In the previous we had it as p, so instead of p it is given as beta, so 1 minus beta. So first is to prove it. So how do we prove? Take the mutual information relation, write the equation I of x is to y is equal to summation I is equal to 1 to n, j is equal to 1 to m, p of xi yj logarithmic to the base 2 p of xi over yj divided by p of xi. Always these are symmetric in nature, so write in terms of y also, you'll be getting it as same. Okay, you can write it in terms of y of x also. I is equal to 1 to n, j is equal to 1 to m, summation p of xi yj logarithmic to the base 2 p of yj by xi divided by p of yj. So we have some unknown constants or unknown things that we need to find out. So those are p of x yj, xi yj, and p of yj. So how do we determine is that? This is your procedure. Steps to determine these things. So first write channel transition matrix. Channel transition matrix. Second one, determine the output probabilities. Determine the output probabilities of y. Then determine probabilities of xi, yj. So fourth one is the whole mutual information of x and y. The first from the figure we should be able to interpret how to derive the channel transition. So the generalized formula is, we all know rows and columns in a matrix. So the first row, this is your row, this is your column. First row, second row, first column, second column. So the first column is always having output as 1, input as 1, 1, 1. The second column we have output as 2, input as 1. So always y is your output, x is your input. So keep in remembrance. So in the second, input is 2, output is 1. So these all are first outputs for 1. All the columns indicates first output. All the columns indicates outputs. All the rows indicates inputs. I repeat it again. All the columns indicates outputs and all the rows indicates inputs. Okay. So first input, second input in rows, first output and second output in columns. So accordingly, when you write, we'll get p of y1 by x1 as your first row, first element, first row first column element, and first row second column element as p y2 x1. Then in the second row first column the element will be p of y1 x2, and in the second row second column we'll be having p y2 x2. So this is a channel transition matrix. Now for this, find the equivalent probabilities from the diagram. So y1 x1 is where? Here it is. It is 1 minus p. Write it here. And next y2 x1. Where is y2 x1? I need to find. So here it is. Y2 x1 is p. So write it p. And next is y1 x2. Y1. Okay, y1 x2 is here. It is p. Next y2 x2. So y2 x2 is 1 minus p. So write it. So this is how to find channel transition matrix. I'll keep this channel matrix transition for 2 or 3 minutes. Then I'll proceed next to find probabilities of output, which is yj. Whenever you solve using matrices, it will be very much easier rather than equations. Let me check for any. Okay. Have a view over this channel transition matrix. Then I'll go for the determination of output probabilities, which is this P of yj. Okay. Here comes the next big question. How to find this? How to find this? Output probabilities. Okay. So the output probability is P of yj is of 2. So we are having how many symbols? 2 symbols, y1, y2. So we should write it as it is. So P of y1, P of y2. So when do we get this P of y1 and y2? When do we get this y1 and y2? We get when there is an input of x1 is being applied to either y1 and to either y2. So the resultant output probability will be P of x1, P of x2 into the channel matrix, channel transition matrix, channel transition matrix. So the x1, x2 in terms of row into channel transition matrix. This is how do we find. So what is this channel transition matrix? Channel transition matrix is here. Just now we are found 1 minus p, 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 1 minus p. So write it here. What is p of x1? Go to the diagram. P of x1 is beta, P of x2 is 1 minus beta. So beta, 1 minus beta into 1 minus p, 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 and 1 minus 2. So next, now you all are familiar what to do with the matrices. Just simply, what is this? Dot. So multiply them. This row into this column, this row into this column. Okay, row versus column. So beta into 1 minus p, and 1 minus beta into p. Next, beta into p, and then 1 minus beta into 1 minus p. So simplify, we will be getting this. Then what is this all equivalent to? When we simplify this, we'll get beta plus p minus 2 p beta or 2 beta p. The next we'll get 1 minus beta minus p plus 2 beta p. So what are this? So these are equivalent to p1 and p2, py1 and py2. So py1 will be beta plus p minus 2 beta p, which we wrote in earlier as it as alpha. Okay, can derive it as alpha. So this we are assuming it as alpha, such that the 1 minus alpha, which is beta plus p minus 2 beta p, is 1 minus alpha. Then you can see that whether we are getting this equation. So this is alpha and this is 1 minus alpha. So we'll be getting the probabilities. So this is how to determine P of y1, P of y2, which is in general we call it as P of yj. Tell this. P of y1, P of y2, both are being determined. Now next is that we need to find P of xi yj, because as per our requirement we had found yj, we had found okay, we had found P of yj, P of y1 and P of y2 for these two. Next we need to find this P of yj by xi or P of xi by yj. Okay, so that we'll see. The joint probability P of xi yj is given as this equation. Okay, P of x1 y1 is equal to y1 over x1 of x1. Since there are four resemblances, we need to determine all the four. So y1 x1 with respect to x1, what do we get? 1 minus p into beta, which is beta minus beta p, and x1 y2 is obtained in this case p y2 by x1 of x1. See that these are your inputs, x1 are your inputs, y1 y2 are your outputs. Okay, so we get beta into p. Similarly, x2 as input, y1 and y2 as output. What do we get? So x2 as your input, x2 as your input, and y1 y2 as output. We get p into 1 minus beta is equal to p minus beta p is equal to 1 minus p into 1 minus beta, which is 1 minus p minus beta plus beta p. So this is your probability, joint probability of x and y we had found. So the last remaining is your determining your mutual information. So this mutual information can only be determined by having all the all the relations. Okay. So now since we are having two symbols, okay, x2 and y2, so substitute them with I is equal to 1 to 2 and j is equal to 1 to 2, p of xi yj log to the base 2 p of yj over xi divided by p of yj. So we will be getting four different equations since there are two. Okay, so p of I2 and j2, so totally four. So p of x1 y1 plot to the base 2 p of y1 over x1 divided by p of y1 plus p of x2 y2 plot to the base 2 p of x2 over x1 divided by y2 plus p of x2 y1 log to the base 2 p of y1 x2 divided by p of y1 plus p of x2 y2 log to the base 2 of p of y2 by x2 divided by p of y2. So here there is an scripting mistake. Here in the second it should be x1. I regret for this. scripting mistake. Here it should be x1. Okay. Here, which I'm highlighting, which I'm showing an arrow mark is x1, because here x1 is your input. So here x1 input is written correctly, but here it is scripted wrongly. So x1 should come here. Okay. So now find these values. Where is p of x1 y1? Find it. x1 y1 is this, beta minus beta into p. So substitute logarithm to the base 2. Where is this y1 x1 y1 x1? We are saying y1 x1 somewhere over y1 x1. So is this y1 x1 over y1. Okay, we will find this y1 x2 first. Where is this y1 x2? y1 x2. Okay, p of y1 is alpha. We have substituted y1 over x2. Let me check where is it. Here it is in the given question. y1 x2. We require y1 x2. Yes. P of y1 over x2. y1 over x2 is p. So substitute that. Then p of x2 y2 is here. x2 y2 is here. Substitute that, divided by p of y2. So p of y2 is here. Just over. So next is this. Next is x2 y1. P of x2 y1 is this. Log to the base 2. We have p of y1 x2. y1 x2 is p divided by p of y1. P of y1 is alpha. So p by alpha. Then the fourth one is p of x2 y2. P of x2 y2 is this 1 minus p minus beta plus beta p. So bring it here. Plot to the base 2. We have, what do we have? P of y2 x2. We'll go back and see p of y2 x2. y2 x2 is 1 minus p. 1 minus p divided by p of y2. P of y2 is 1 minus alpha. So this would be your equation, basic equation for determining. So afterwards we need to simplify this. Let's simplify. Okay. So simplification is your procedure which you all are much familiar even than me also, I think so. So minus, take it common outside, minus of beta plus p minus 2 beta p logarithmic base 2 alpha minus of 1 minus beta plus p minus 2 beta p logarithmic to the base 2 1 minus alpha plus p logarithmic base 2 p plus 1 minus p logarithmic base 2 1 minus p. So on simplifying, we'll be getting this equation: minus alpha log to the base 2 alpha minus of 1 minus alpha log to the base 2 1 minus alpha plus p log on the base 2 p plus 1 minus p log to the base 2 1 minus p. This is simplification. So from this, h of y can be obtained as we are determine I of x is to y. So from this we can determine h of y also, entropy of y alone, as minus alpha log to the base 2 alpha minus of 1 minus alpha log to the base 2 1 minus alpha. On rearrange this, we get alpha log the base 2 1 divided by alpha plus 1 minus alpha log the base 2 1 divided by 1 minus alpha. Now simplify in order to find the shoe function of this problem. So we get h of phi plus p of log to the base 2 p plus 1 minus p log to the base 2 1 minus p. So we get substitute this equation. Substitute this equation, we get shoe function as p log the base 2 1 by p plus 1 by 1 minus p log to the base 2 1 divided by 1 minus p. So which we get minus p log to the base 2 p, taking inverse, so minus will be coming here. So this also same, minus of 1 minus p log to the base 2 1 minus p. So taking the whole minus common as that side, minus of p log to the base 2 p plus 1 minus p log to the base 2 1 minus p, which is minus shoe function. This is your minus of your shoe function. So we can write the equation mutual information is equal to h of y minus shoe function of p. Okay. So now take this equation. So this is your equation we have got. This equation h of y plus p of log to the base 2 p plus 1 minus p log to the base 2 1 minus p. So this equation is what here we have determined. H of y plus p log to the base 2 p plus 1 minus p log to the base 2 1 minus p. Okay. Now for this we need to find for if the value of p is some value and beta is some value. Okay. So what how do we find shoe function? How do we find entropy of that function? Okay. So simply put p is equal to 0.1 as given in the question and beta is equal to 0.5 as given in the question to this problem. So we'll get shoe function as this minus of p, which is 0.1 of the base to 0.1 plus 1 minus p, which is 1 minus 0.1, which is 0.9 up to the base to 1 minus 0.1, which is 0.9. So we get 0.469. And now next we need to find alpha. So alpha can be easily found by using the formula beta plus p minus 2 beta p. So beta is 0.5, p is 0.1. Simplify, we get alpha is equal to 0.5. Now next, how do we find entropy? H of y is given alpha log to the base 2 1 by alpha plus 1 minus alpha log to the base 2 of 1 minus alpha. So alpha is 0.5, substitute and we can find that entropy of this is 1 bit per symbol. Simplify using logarithmic table correctly. We'll get 1 bits per symbol. Now, substitute these values, all these values, h of y, p value, beta value, and alpha value in this equation. So we get the mutual information as 0.531 bits per second. Approximately, we can give that zero point 0.5 bits per symbol will be transmitted. So 0.5. So for every information, since we have for a single output, we have two dependents x1 and x2. At a particular time, out of these two, any one will occur. So this has a probability of half a chance, y1. Similarly, y2 will have a half a chance probability. So this is what we call it as 0.5 bits per symbol. So any one symbol occurrence has the probability function of zero point 0.5 only. For this problem, it is specifically for this binary symmetric channel. So I'll give you 2 or 3 minutes time for this. Binary symmetric. You can go through. Any doubts you can put in the chat box. At the initial time or at the first time when you see these problems, it will be, you can see that it will be very much lengthier. But once if you have got practiced with this type of problems, you can solve it in no seconds. Only if you understand the concept, you can solve it easily. Okay. So when can we solve this it easily is that by only by knowing this formula. Okay. This is your information formula. If the information formula is known, it's very much easier. So write the formula. I need to find p of xi. I need to find p of xi over yi, the yj. I need to find p of xi comma yj, conditional probability, entropy, sorry, conditional entropy, entropy, and joint entropy. So for this, what is the procedure? If you're able to determine that, it's easier. So for that, the procedure is writing the channel transition matrix, determining the output probability, determining the joint probability, and determining the mutual information. If this four procedure is known, you can easily interpret this with the binary symmetric channel. So this binary symmetric channel problems are very much important. Don't worry, all these materials I'll share you after completing this unit, and you can have a practice over that. In some problems they'll give you the p value or beta value as different. That will depend upon the problem or situation. In some cases they may not be given, and they leave it as it is to find only the equation. Problems will come like that also. In some cases different values of p, different values of beta will lead to different values of alpha also. What are might be your values? The procedure for solving the binary symmetric channel is this only. This is how you need to solve it. Mhm. The solving procedure should be followed by determining channel transition matrix, which is the basic criteria. Then probabilities of output, determining the mutual probabilities of input and output, which is xi over yj, and determining mutual information, which is our required. Shall we proceed for the next problem? Same procedure, but a different values will be there. So that's all. Same procedure. Okay, let me check the chat box. If there is any doubt still these five questions. Oh, okay. It's 11:20. Okay, okay, right. Just a minute. Rather than going for the six, I'll show you how many questions that we'll be solving in this unit. I'll just give a glance. I'll give you just a glance of that. Then in the next class, we'll see the remaining problems. I'll show you. We have a seventh question, which is solving for ternary. So sixth is same procedure as a binary. As seventh, we'll be solving it for okay, a binary, not ternary. Sorry, it's binary with given probabilities. The transition matrix is given, so this will be very much easier to solve. Again, in problem number 8, channel transition matrix is given. We need to find only the mutual information. And in yeah, problem number 9 would be quite difficult for us when we compare with the binary symmetric channel, which we call this as M array, or M is equal to 3. We take it here, which is not a binary symmetric channel, which we call as ternary channels. Since 3 rows, 3 columns are being used. We'll solve that. Then we'll solve a simple problem on determining the equal probability of messages. So with that, we will complete the problem sections in unit 2. So now let me go for the attendance and just stop presenting it. Okay. Okay. So this time every time we'll have a different form of attendance taking. One time I'll send you Google Forms. Sometime I'll be calling you. So I got some feedbacks about these two types. So now I'm going to take attendance using the chat box. What you do is that type your register number in the chat box. Type your register number in the chat box and you can leave. Check whether your register number is being typed in the chat box and then leave. Okay, the remaining, I'll if you are typed in the chat box, I'll take it as you are being present. Because I received so many feedbacks that the students those are not attending are also getting attendance in Google Forms, and in some calling somebody is being getting missed. So make sure after typing whether your number appears in the chat box. If it is appeared, you can leave. I hope everyone can understand and are able to see. Okay, sorry, I didn't know. Okay, I'll show who all are being present. So those persons can leave. I think you can see 16, 16 can leave, 53, C053 can leave, C023 can leave, C103 can leave, 150 can leave, 31 can leave, 71, 72 can leave, 154, okay, 154 can leave, 34 can leave, 35 can leave, 9 C009 can leave, triple one Kishore, yeah, C triple one Kishore can leave, C022 can leave, 22 next, 28. I'm showing you this is same screen. I'm showing you who all are in the chat box. Those are given their attendance. 28 Shrikar, yeah, can leave. Who else are present? Pranit, I think 61. No, no. 61. I think Pranit has slept. Pranit, are you there? Pranit? Pranit Reddy, you're able to listen? Yeah, Shrikar can leave. Your, your number is appeared. C028. Sai, Sai, Pranit.